Okay, so now we're here on the mill. I have one of our casing blanks in my indexer here. This is a really nice one. I just got to replace my collet block setup I was using before. So this has a lever, and you can set, with this is a hard-hinge indexer, so it has little set screws back here, so you just set the set screw in and that becomes, or is the pin that it sets. And you can set it to only index on certain dash lines. So right now I have it only on the 490s. So that'll make it a lot easier. And that way you can't mess up your indexing points if you have it set properly, obviously. And like if I were to be doing the actual rotor port milling again using this indexer, I would unscrew two of them 180 degrees from each other so that I only have 2 points that I can actually index on, because I have messed that step up a lot, because if those ports aren't in line with the stop arm drive, you're gonna have to have a weird stop arm, and that's just a pain in the ass. So yeah, this is great. I'm really excited to try this out. So where I'm at, I'm going to set myself to 0 here. Doesn't really matter too much which one, as long as they're 90. And it's really rigid. I have it clamped down here, and I have it trammed into this head. So where we're at here is, see, check if you can see it. Yeah, so I have my work here. I just set this up with the vise still on there to be fine. The vise is actually going to come in handy right now because I have a dial indicator here, and that's how I'm going to set. So I have already found my center mark of the x-axis of the rotor, so this direction, and I had just touched off my center on the y, and I have this dial set to 0. So what I'm going to do is the center line of where our porting hole is going to go through the casing here is 0.460 inches away from this edge. So this is pretty simple. I'm just going to watch my dial here, and we're going to get that offset set. Just setting this indicator stand is a little wobbly right now. Okay, so we're set at 0. The wrong way, back to 0. That's 100 thousandths, 200 thousandths, 300 thousandths, 400, and then we're going to go 10, 20, 30, 40, 50, 60. So that's it there. Lock down the the Y, and you can actually see that moved a little bit. So I'm actually going to backtrack. Make sure we're set right. There we go. So that's right on it. 460, and then we can come in and see, just double check with our spot check. Okay, line. So now that we have that offset on the y-axis set, our tables are locked. We didn't lose our mark. So we're not actually, for this, we are not going to be manipulating the hand wheels at all. All we're going to be doing is plunging with the quill. Give myself a little more room on that. And I'm using a carbide 4-flute ball end mill just because I like the way they drill. This is actually going to be the first time I'm trying it with this indexer, so we'll see how that goes. So let me turn on my phase converter here. So yeah, just the way this indexer works is simple. So I have my blank. I actually have a collet stop in here. So we're really just holding on to 100 to 150 thousandths of material. And we have our offset set, so every time we put a new one in, it'll be spot on. So, okay, let's give it a shot, see how it goes. We're bottoming out on the quill stop. We're getting some weird chatter. I'm actually just gonna That'll take care of that. There we go. It's up. And all we have to do is hook it next, and that locks in. Yeah, that's awesome. I don't have to turn it off. Go next. Keep going to turn on the machine, it's funny. We have our last one. Locked in. So when the tool's starting to grab on there, this is the reason I like to use ball end mills, because they tend to not grab as much as a twist drill. Is because I had my quill a little too loose, so I like to, just like with drilling with a tailstock on a lathe, you want to keep a little quill pressure. But yeah, that worked out great. Just comes out that easy. No more messing with channel locks in a collet closer, or in a collet block. So now we have our porting, and these are 468 holes. Eventually I might get a metric, like metric would be 472. That might be too much clearance. Because right now I just scrape out these holes, because our knuckles are 468 as well, and that's a little bit too tight of a fit. So we have our holes in. It looks pretty good. This is a test piece I'm doing in brass, just so I can make sure, since this is the first time I've ever made this type of rotor. I might have too shallow of a section between the top of that port and that thread boss, or gutter, I should say. So I don't know. I'll have to tune that in. What I'm going to actually go ahead and do is I'm not going to braze casings into this one. I'm just going to ream it out to the Morse 3 on the inside, and then I'll do some test fits with the rotor. Just to make sure that we're going to be lined up correctly. I can already see we're not going to be. I need to adjust that offset. Well, actually, no. Depends on how you look at it. I might adjust a little bit. If you can see, I just want to make sure we have even enough, excuse my fingernails, I've been working a lot, even enough gap for the bearing press-ins on the top and bottom. So I can see it going a little bit more that way, but not much, maybe 10, 15 thousandths. Let me actually measure where we're at. Yeah, so that gap's at about 40 on the machine, which is about 10 shy of where I had it planned. This was the first test, and it was too far the other direction, way too much space between that gap. So I'm going to go ahead and bring this out, and we'll see.